Hello students. Today is the 7th lecture session, part 1. Topic of the lecture: Telecommunications and Networks. In this video, we will cover the following topics. Introduction. Telecommunications network. History. Components of the local network. Conclusion. Introduction. The basis of the theory and technology of telecommunications is the transmission of various kinds of messages, information, over a distance. Under the information, to understand the totality of information on any objects, the events, processes of one's activities, etc. The form of presentation of information is called a message. It can be speech or music, handwritten or typewritten text, drawings, television images. For transmission over communication channels, each message is converted into an electrical signal. Signal is a physical process that displays the message being transmitted, the physical medium of the message. The physical quantity of the change, which provides the display of messages, is called an informational or representative signal parameter. A telecommunication system is a complex of technical means providing electrical communication, telecommunication, of a certain type. The above definition contains the keyword telecommunications. What is it? Telecommunications, transmission or reception of signs, signals, texts, images, sounds over a wired, optical or other electromagnetic systems. The concept of telecommunication networks is closely related to the concept of telecommunication systems. Telecommunication network is a technological system that includes communication facilities and communication lines and is intended for telecommunications. The product of the functioning of the telecommunication system for receiving, processing, transmitting and delivering messages is usually defined as a telecommunication service. It should be noted here that any natural or legal person ordering and/or using telecommunication services is called a user. The term subscriber is narrower and is used to refer only to those individuals or legal entities with whom an agreement has been concluded on the provision of communication services to whom when a subscriber telephone number or a unique identification code is allocated for these purposes. A form of communication is a method of transmitting messages in a network, which is characterized by the principle of converting a message into a signal and by the type of communication. Telecommunications network. Telecommunications networks include computer networks for data transmission, telephone networks, voice data transmission, radio network, voice transmission and broadcast services, television network, voice and image broadcast network services. History. Telecommunication is the science and technology of communication at a distance. The ability to communicate information quickly, accurately and efficiently has always been one of the main directions for the development of human innovation. From prehistoric man with his signal lights to modern high-level executives with the latest smartphone, communication is still the key to survival and success. The history of telecommunications illustrates this endless push for progress, as it steadily parallels human growth, becoming more widespread and effective as modern civilization develops. Prehistoric era. Signal fires, beacons, smoke signals, communication drums, horns. Man's early attempts at remote communication were extremely limited. Primitive man relied on fire and smoke signals, as well as drum messages, to encode information in a limited geographic area when they tried to contact neighboring tribes. These signals also had to have very simple, predefined meanings such as safe, or danger, or victory, or could be used as an alarm system to alert prehistoric tribes, for example, about an intruder. Appearance of male. Cyrus the Great was a Persian king during the heyday of Persia in the 6th century BB. The Persian state during his reign was so vast that there were difficulties with communication. Messages and orders from the capital to remote regions reached a very long time. Cyrus the Great did not put up with this disgrace and became the first inventor of mail. In any case, it is he who is credited with creating the first postal system in world history. Other ancient powers such as Egypt, Rome and China eventually established their postal systems later. Pigeon mail. Persia and Syria are credited with creating the first messaging system using pigeons around the 5th century BB. Due to the discovery that pigeons have a strange ability to find their way back to their nests regardless of distance. The travelers brought pigeons with them, attached messages to them, and released them so they could return home. Later, pigeons would be used by the Romans for sporting events and the Egyptians for military messages. Heliograph. The heliograph, a shield signal, was first documented during the famous Battle of Marathon, which took place in 490 BB. Between the Greeks and Persians. The heliograph included the glow of the sun on a polished object such as a shield or mirror. Interestingly, in this case, this signal was not really understood, as its meaning was not clearly agreed upon prior to its use. Sea flag semaphore. The semaphore of the sea flag was the ability to communicate between ships. Before his invention, communication between ships was very complex, but the semaphore greatly simplified it. The special code was transmitted by the positions of the two hand flags. Each position and movement was represented by a specific letter or number. This allowed the crews of different ships in the fleet to communicate with each other very easily. Semaphore signaling system. Robert Hooke is first credited with creating the first acoustic telephone in 1672. Hooke discovered that sound could be transmitted through wires or strings to an attached earpiece or mouthpiece. However, it is unclear whether he knew of the implications of this discovery, as his notes indicate his desire to use this device to create music. Early history of the telegraph. In 1790, semaphore lines optical telegraphs appeared. Using the semaphore of the sea flag as a starting point, the Chap brothers, two French inventors, created the first optical telegraph system in 1790. The optical telegraph was a system of pendulums mounted somewhere high, on the tower or top of the city clock. The telegraph unfolded its mechanical arms and sent messages from tower to tower. It was the first telecommunication system in Europe. Morse Code. Samuel B. Morse worked on the idea of recording the telegraph with friends Alfred Wheel and Leonard Gale. They found that by connecting two telegraph models together and passing electricity through the wires, messages could be sent by holding or releasing the buttons at a series of intervals. This became known as Morse Code and laid the foundation for modern landline telephones. Transatlantic telegraph cable. In 1858, the first transatlantic telegraph cable appeared. At this stage, most of Britain and the US had telegraph stations and could communicate regularly in their respective countries, but a man named Cyrus Field from New York wanted to lay the first transatlantic telephone cable to connect England and the US by telegraph. This project, despite numerous setbacks, was finally completed in August 1858. The invention of the telephone. 1876 was a life-changing year for inventor Alexander Graham Bell. Arriving in the United States as a teacher for the deaf, he tried to find a way to transmit speech electronically. Despite little support from his friends, he first made a telephone in its modern sense in March 1876. Acoustic phonograph. Inventor Thomas Alva Edison made incredible progress in recording and transmitting sound when he completed the first acoustic phonograph in August 1877. He was trying to improve and refine the phone model when he realized that by connecting a needle to a phonograph diaphragm and a tin-foil cylinder on which the needle could record spoken words, he could record and reproduce sounds. Photophone. In 1880, Alexander Graham Bell took the money he had received for the successful creation of the telephone, set up a laboratory, and set to work on improving his invention. The fruit of his labor was a photophone, a device capable of transmitting sound in a beam of light. In fact, Bell made the first wireless call ever. Wireless telegraphy. The genius scientist Nikola Tesla was the first to successfully transmit radio waves wirelessly via the transmitter in 1893. He patented his work, and he was lucky because shortly thereafter, Guglielmo Marconi, another inventor, claimed that Tesla had copied his work. In the ensuing trial, this was found to be untrue. Tesla continued to experiment with wireless transmission and tried to create a more efficient AC light bulb. The invention of radio. Undaunted by his defeat in the escorts, Marconi continued to work on his own versions of wireless audio transmission. In 1896, he sent his first long-distance wireless transmission. The signal was sent to a distance of 2 kilometers. The recipient of this signal waved a white handkerchief to indicate that it was received. This earned Marconi a place in the history books as the person who invented radio. First transcontinental phone call. Alexander Graham Bell wrote his name back in history after he made the first coastal call to his assistant in January 1915. This was the first ever long-distance call from a landline phone. This event was significant because it made communication across the country by telephone a reality. The invention of the television. Philip T. Farnsworth made history on September 7, 1927, when he demonstrated the first working television set. While working on a method for transmitting images, he discovered that it was possible to encode radio waves using an image and then project them back onto a screen. This is how television first appeared. First radio telephone service. The first radio telephone service from Great Britain to the United States was established in January 1927. Phones were originally radio telephones, so there were some problems with fading and interference. Originally it was only one channel, and it received about 200 calls a year, and the cost of 3 minutes of conversation was almost $10. The first experimental videophones. In 1930, AT&T decided to create a double-sided experimental videophone, which they called the iconphone. This allowed people to see, hear and respond to those with whom they spoke in real time. The idea, while excellent, did not have much commercial success. First commercial radio telephone service, USA Japan. The first radio telephone calls from the United States to Japan were first made in 1934. This allowed people to speak across the Pacific for the first time. Unfortunately, due to the distance, the call quality was not very good. There was a lot of fading and noise. US Japan Radio Telephone Circuit, 1935. 6 years before the attack on Pearl Harbor, radio telephone service was inaugurated between the United States and Japan. Shown here is Chiduko Kashiwagi, the Japanese telephone operator at the Tokyo end of the circuit. The radio link was between the transmitting stations at Dixon, California and the receiving station at Komoro, Japan. The signals going the other way went from Nozaki, Japan to Point Reyes, California. The control points were located at San Francisco and Tokyo, from which points the signals were linked to the respective national telephone networks. Transatlantic telephone cable. The first 36-channel transatlantic telephone cable was installed in 1956. The cable stretched from Newfoundland to Scotland. Thanks to him, phone calls have become much cheaper. Fiber-Optic Communication. In 1964, Charles Kao and George Hawkham published an article in which it was proved that fiber-optic communication is possible if the fibers used to transmit information do not contain impurities. This discovery reopened the door that Alexander Graham Bell first created with his photophone, allowing sound to be transmitted through beams of light. The first computer networks. In October 1969, the first data was transferred between the ARPANET nodes, the predecessor of the modern Internet. It was the first computer network invented by Charlie Klein and Bill Duvall. First mobile phone. In 1973, inventor Martin Cooper called his Bell Labs rival Joel Engel on his cell phone for the first time. The first mobile phone had a maximum talk time of 30 minutes and took a year to charge the battery. This phone will eventually become the prototype of Motorola's first mobile phones. First mobile network. The history of widespread mobile telephony began in the early 1980s. It was then that the 1G network was created. It was an abbreviation of the English one generation, first generation. The following networks were named accordingly. The first commercially automated cellular network was launched in Japan in 1981. This network was originally only launched in Tokyo in 1979 and has since been expanded. At the same time, a Nordic mobile communication system was organized in Denmark, Finland, Norway and Sweden. St. P. Email. Until 1982, the Internet, or rather its ancestor ARPANET, was very secure and consisted of limited network clusters between military, corporate and some university research centers. In 1982, Jonathan Postel wrote a simple mail forwarding protocol and shifted the Internet's focus from security to reliability, using networks as relay stations to send email to a recipient through shared hosts. The emergence of the Internet. On January 1, 1983, the Internet was officially born. ARPANET officially switched its old network control protocols (NP) and transmission control protocol. The Internet Protocol, TX/IP, has become a standard. Components of the local network. Network card. To organize a local network, you need to install a network card in each PC and connect all computers using a special cable. A network card, also known as a network card, network adapter, Ethernet adapter or NIC, network interface controller, is a peripheral device that allows a computer to communicate with other network devices. Currently, especially in personal computers, network cards are quite often integrated into motherboards for convenience and to reduce the cost of the entire computer as a whole. According to the design, there are internal separate cards that are inserted into an ISA, C or CE slot. External, connected via duct LP, USB PCIe interface, mainly used in laptops. Built into the motherboard. Y connector type. PC, 8 position 8 contact for twisted pair, RE. B-bun connector for thin coaxial cable. 15-pin LV transceiver connector for thick coaxial cable. Optical connector, 10 base FILI and other 10-bit Ethernet standards. These connectors can be present in different combinations, sometimes even all three at once, but at any given time only one of them works. MAC address. A MAC address is a unique serial number assigned to each Ethernet network device to identify it on the network. The MAC address is assigned to the adapter by its manufacturer, but can be changed using the program. The MAC address is 6 bytes long and is usually written in hexadecimal format, for example, 12, 34, 56, 78, 90, AB. Colons may be missing, but their presence makes the number more readable. Each manufacturer assigns addresses from its own address range. The first 3 bytes of the address identify the manufacturer. The MAC address is used to determine the destination of packets, frames, on an Ethernet network. When working, network adapters scan all passing network traffic and look for their own MAC address in each packet. If there is one, the device adapter decodes this packet. There are also special ways to send packets to all devices on the network simultaneously, broadcasting. Cables. Coaxial cable. Coaxial cable transmission speed up to 10 bit/s. This is one of the first conductors used to create networks. It contains a central conductor, an insulator layer in a copper or aluminum braid, and an external PIC insulation. The maximum data transfer rate is 10 bit. The cable is quite susceptible to electromagnetic interference. Twisted pair. Twisted pair, transmission speed up to 100 bit/s. It is currently the most common network explorer. In structure, it resembles a stranded telephone cable, has 8 copper conductors intertwined with each other, and a good dense insulation of polyvinyl chloride (PEC). Provides high connection speed up to 100 megabits/s, about 10-12 m/s, or up to 200 Mbit in full duplex mode. When using gigabit hardware, speeds of up to 1000 Mbit are achievable. See 1000 megabit network gigabit LAN. Fiber-optic cable. The cable contains several optical fibers, well protected by plastic insulation. It has an ultra-high data transfer rate up to 2 bit. Absolutely not subject to interference. The distance between the systems connected by optical fiber can reach 100 kilometers. The cost of an optical cable is quite high, about $1.3 per meter, and to work with it requires special network cards, switches, etc. Without special equipment, fiber is almost impossible to repair. Cable connectors. For coaxial cable. For twisted pair. Communication between access points, but also connect client computers at the same time. This allows you to achieve significant hardware savings and simplify the network topology. This technology is supported by most modern access points. Conclusion. From the very beginnings of the telephone and telegraph industries, the evolution of the communications sector has fundamentally transformed social and economic relations. Virtually all collaborative work within and between organizations depends on electronic interaction. Personal communications have moved beyond simple voice communications to encompass email, instant messaging, text messaging, and online virtual communities. Thank you for your attention. Goodbye.